Okay, so this is a proof that where you have to use CPCTC. And CPCTC is corresponding parts of congruent triangles are congruent. And you use CPCTC when you're trying to prove that two segments or two angles are congruent instead of two triangles are congruent. Okay, so yeah. The given says that DE is parallel to JK and that DK bisects JE. And we're trying to prove that DE is congruent to JK. Okay, so first write your given, and then second, angle JGK and angle DGE are vertical, so usually in the given, if it says that two lines are parallel, you're going to use your transversal theorems. And by using alternate interior angles theorem, you can say that angle J is congruent to angle G, or angle D is congruent to angle K. I'm just going to say that angle J is congruent to angle E, and that would be alternate interior angles theorem. And then I would say that since DK bisects JE, DG and GK are congruent. And that's definition of angle bond. And then you can say that triangle DEG is congruent to triangle JGK, JKG, by angle side angle. And you can prove that two triangles are congruent by angle side and angle, angle side, side side, angle. Okay, ASA, SAS, SSS, and AAS. And then you could say that for the last step, DE is congruent to JK by CPCTC. Okay, so this is a way harder one, sort of. Okay. The given says that TO is congruent to OH and PO is congruent to OB, and that angle JTH is congruent to angle JHT. And we're trying to prove that segment PJ is congruent to segment JV. And to do that, we'd have to use CPCTC and prove that this triangle is congruent to this triangle, because they both share these segments here, kind of. Yeah. So first I would try and prove that this angle is congruent to this angle, and that'll be like the hardest part of this proof. Okay, so since OH is congruent to OT, you can use isosceles triangle theorem that says that the angles opposite would be equal. So this whole angle here and this whole angle here is equal. And since these two are equal, we can like subtract them from it. So angle VHT is congruent to angle PTH by isosceles triangle theorem. And then I would say that angle VHJ plus angle JHT equals angle VHT. And angle PTJ plus angle JTH equals angle PTH. And that would be angle addition postulate. And then I would say that angle PHJ is congruent to angle PTJ by substitution, I'm pretty sure. Or like subtraction. Okay. And then step 5, I would say that TJ is congruent to HJ because converse isosceles triangle theorem, because these two triangles are equal, so that means that this side and this side is equal. And yeah. And then I would say that this angle is congruent to this angle because vertical angles so angle PJT is congruent to angle VJH by vertical angles theorem. And then 7. Triangle PJT is congruent to triangle VJH by so angle side angle. And then our last step is that PJ is congruent to JV. CP, CTC. And then that's it. But you also could have proven that this side is congruent, or segment BH is congruent to segment PT, because this whole side is congruent to this whole side, and this side is congruent to this side. So you could have just used subtraction and gotten that this side is congruent to this side. And then that would have been side angle side.